Lesson 6, we're going to solve two-step inequalities. So we've solved two-step equations. This is going to be the same process. The only difference, like we talked about in the last lesson, is that at the end of the problem when you're solving these, if you have to multiply or divide by a negative, your inequality symbol is going to switch. The steps are identical to what we did when we solved equations, though. So if you look at example 1 on page 290, Hamish has $25.97 in his pocket to spend at the craft store. He wants to buy a paint canvas and some paint pens. How many paint pens can Hamish buy? So if you look at the picture over here, you can see the canvas is $14. Paint pens are $3.15 each. So he's going to buy a canvas, meaning one, and some paint pens, meaning hopefully more than one. Okay, so you can see what they did. First of all, they came up with an inequality. So the cost of the canvas is $14. Pens are $3.15 each, so $3.15 times however many pens we buy, and that total needs to be less than or equal to $25.97. We're going to solve the inequality then. Solving the inequality again is going to be looking a little different maybe than what the book's doing this. So you could say we're going to try and get that variable term by itself. They're adding 14. We're going to subtract 14 on both sides. And again, we'll usually do that underneath rather than how the book's showing this. If you subtract, that's $11.97. And then they're multiplying, so we need to divide. So we divided by $3.15. We did not divide by a negative number, so our inequality stays the same. P is less than or equal to 3 80/100. So we can buy like 3.8 paint pens. In this case, though, like the book says, is that we can only buy whole paint pens, so he would have to only be able to buy 3 or fewer paint pens then. You can see they graphed that on the number line. The first whole number answer that actually works is 3, and obviously 0 actually would be the lowest. We can't buy negatives, but technicality there. So Erin has $52 to spend at the florist. And she wants to buy a vase for $11.75 and several roses for $3.50 each. What are the possible numbers of roses Erin can buy? So this isn't necessarily just saying, one answer. We could be looking at multiple answers that they're wanting us to tell for this. So first of all, we need to set up our inequality. So we know our vase is $11.75. We're only buying one of those. And then the roses are $3.50 each. This is our budget, so the amount we spend over here has to be less than or equal to 52. So that should be our inequality to start out with. They're not giving you like any room to work this out, so we might want to work that off to the side or something. So first of all, to get this variable term by itself, they're adding, or we have a positive 1175 we need to get rid of. We need to subtract 1175. When you subtract, if you were doing this by hand, obviously we'd have to do some borrowing in order to work that out. Should be $40.25. At that point, our variable is being multiplied, so we would need to divide by the $3.50. Whoops. And that would be 11.5. So the number of roses Erin could buy has to be less than or equal to 11.5. So if we go back to what they said in your book here, it says Aaron can buy up to 11 roses. And that would really answer the question. I mean, if you wanted to give every single answer, we could say, you know, she could buy 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, or 11. And that would cover it. But up to 11 roses probably is sufficient. Example 2, members of the science club are selling coupon booklets for $17.95 as a fundraiser. They hope to exceed the amount of money they raised last year. How many more coupon books B must the club members sell to achieve their goal? So they're $17.95 each. And again, they're hoping to exceed the amount they raised last year. So if you look at the information over here, you can see last year they raised $658.35, and so far this year they've raised $498.75. So they started off with an inequality, so they said they've already raised $498.75 plus $17.95 times however many more booklets they're going to sell, and we want that to be greater than $658.35 that they raised last year. Once we set up that inequality, it's basically the same steps like we've been talking about. So you could say that they're adding, or we have a positive number here we need to get rid of, so you'd need to subtract 498.15. Again, we would probably show that underneath. Is it 15 or 75? So this actually is a typo. This should be 498.75. Okay, and then those cancel, and then they're multiplying, so we would have to divide by 17.95. Again, we're just dividing by a positive number, so the inequality is not going to change around directions or anything. When we do that, we got B is greater than 8.89. But again, we're not going to be able to sell part of a book, so we would have to round up in this case because we're looking for something greater than that number. So it means we would have to sell at least 9 booklets in order to exceed last year's fundraising amount. So we look at the try it. The jazz band needs to raise at least $600 to travel to an upcoming competition. The members of the band have already raised $350. They sell calendars for $8 each. How many calendars would they need to sell to exceed their goal? So we can think about what's happening here. Technically on this, we don't really have a variable defined, so that would be a first step maybe we would consider. So we could do something like let C represent how many more calendars they need to sell. If you picked a different letter, that's fine. So they already have $350 and then $8 per calendar. That's the amount they're raising. That has to exceed the goal, would have to be then greater than 600. Okay, there's other ways we could set up an inequality. Okay, if you did 600 minus 350 and think about that they need to still raise $250 and then say, 8C needs to be greater than 250. That's fine. If you'll notice, as we do this problem, that's what we're going to be doing anyway. But either way would work. So you subtract would be 250, and then so we need to divide by 8. When you divide that out, it would be 31 and 25 hundredths. If you were dividing that out by hand, we had a good observation here. If you were dividing that out by hand and you got 31 point something, you technically could stop at that point. You know you're going to have to sell the next number. You're going to have to sell 32 or more calendars. Another good observation we had here, if you worked this out, and let's say it just came out as 31, greater than 31, we'd still have to sell more than that. We would still have to sell 32. That's not how it came out, but in other words, even if it came out exactly as a whole number, we still got to bump it up one to that next number. So example 3, they want us to solve this inequality. Difference is we have a little bit more of negative signs and things happening, so we just have to be careful about that. If you wanted to, at the beginning here, you could add the opposite first if you'd like. What we want to think about is we want to get that variable term by itself. We want to get the negative 9 halves x by itself. So really, to get that by itself, we have to get rid of this negative 10. To get rid of a negative 10, what would we have to do? Good. We would need to add 10. We need a positive 10 to cancel out a negative 10. So 80 plus 10 would be 90. So we could say, since they're multiplying by negative 9 halves, we could divide by negative 9 halves. I know that's not the way the book's showing, but if you'll notice here in a minute, we'll be exactly at the same spot. So dividing fractions again is keep, change, reciprocal. Good. When you multiply, so we get negative 180 over 9, and then you divide that out, and you get negative 20. One thing is here, we just divided by a negative, so that's going to switch that sign around. It's going to switch to greater than. So that's why it comes out as x is greater than negative 20. So if we look at the try it at the bottom of the page, again, we have to be careful that we're doing the right thing when we're working out these problems. In other words, people look at this problem sometimes and they say, oh, they're subtracting, I need to add. You may want to add the opposite first here and think about basically that we want to get the negative 1/2 x by itself. We want to get rid of the 5. So there's not a sign in front of the 5 means it's actually positive. If you want to put a positive 5 there, you can. How do we get rid of a positive 5? Subtract 5. Good. So when you do that, those will cancel. And then they're multiplying, so we can divide. Once again, we're dividing by negatives, so our sign's going to switch. When you divide that out, you'll get negative 50. X is less than negative 50.